All right, let's look at inverse trig functions. This notation, y equals sine of negative 1x, means the inverse. So it means that we switch the x and the y. Recall that inverse, you're going to switch the x and the y. So now we've changed our domain and range. So in a sine graph, remember that our domain is all reals, and our range is from negative 1 to 1. All right, let's graph this function. Let's graph the sine function. So it's 0, high, 0, low, 0. And reverse the pattern. All right, so that's the sine graph. Now notice here that if we take the inverse of this, if we use the horizontal line test, the inverse of a sine graph will not be a function because a horizontal line touches our graph in more than one spot. So here we want to make a restriction. We want the inverse to be a function. So that means we need to restrict our range in order for the in order for the inverse of this to be a function. So we're going to restrict our domain between negative pi over 2 and positive pi over 2. So that way, when we take the inverse, it will also be a function. So our restriction is going to be from negative pi over 2 to positive pi over 2. And if you read at the beginning, in order to obtain a unique theta for each a trig function has an inverse, you must restrict the domain. Domain restrictions allow the inverse functions to be defined. Now, another way of representing the inverse sign is also called the arc sign. The arc sign of x is just another notation that means the inverse of sine. You're going to switch your x and your y. So y equals the arc sign of x. And we'll show you how that comes to play in a minute. All right, let's look at the same thing with the cosine function. Here again, let's graph our cosine function. All right, so this is our pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so this is 1. So high, 0, low, 0, high, and reverse it. All right, so here is our cosine function. All right, again, notice that if I draw a horizontal line, the inverse of this is not going to be a function. So here again, we're going to restrict it. We're going to restrict our domain so that when we take the inverse, it will also be a function. All right, so where are we going to restrict this? If I do it between negative pi over 2 and pi over 2, the horizontal line is still going to touch it twice. So that's not going to be a restriction. So let's go to the closest thing around 0. What if we start at 0 and end at pi? So we're going to restrict it to just this part of the graph, because then our inverse will also be a function. So that restriction on here is from 0 to pi. And the whole goal of this is to keep so the inverse will also be a function. Here again, we can write the inverse cosine of x as y equals the arc cosine of x. All right, finally, let's look at tangent. All right, with tangent, remember we have asymptotes at pi over 2 and 3 pi over 2, and negative pi over 2 and negative 3 pi over 2. I'll let this be 1. All right, every one of my scale is pi over 2 here. All right, so let's draw our tangent function. All right. Now here again, notice once again, if I draw my horizontal line, it's going to touch my graph in more than one spot. So the inverse of tangent is not going to be a function without some restrictions. So let's decide where are our restrictions. We want to keep the inverse also a function. Alright, so hopefully you noticed here, if we restrict this thing between negative pi over 2 and pi over 2, then we'll have a function. But the negative pi over 2 and pi over 2 are asymptotes, so that means this is open. So we're from negative pi over 2 and positive pi over 2. Where it was closed in sine, it's now open in tangent because there's asymptotes at pi over 2. Alright, other notation, the inverse tangent can also be written as y equals the arc tangent of x. And you should be, like I said, be able to understand either one of them, that kind of notation. Alright, how is this? How are we going to use this? Why are we doing this? Alright, here's the types of problems you're going to be responsible for. Evaluate the expression in both radians and degrees. So this is inverse. So our answer is going to be an angle. This question is asking, is the inverse cosine of -1, wants to know what theta, what angle, has a cosine of -1. Let's go backwards. We're restricted from 0 to pi. Alright, so where do we have an x value of -1? So -1, 0 corresponds to pi. So the inverse cosine of -1 is equal to pi. Alright, let's try the second one. Alright, tangent. We're restricted from from negative pi over 2 to pi. Alright, what angle has a tangent of square root of 3 over 3? Should be the 30-degree family. Now, since this is positive, we want the 30-degree family. We're in the first quadrant and the fourth quadrant. Tangent's only positive in the first quadrant. So that means our answer is pi over 6, which is the 30-degree family. Alright, so they want it in radians and they want it in degrees. So that means we should have had this answer as 180 degrees also, because that's what the directions are asking us for. Alright, inverse sine of 0. Alright, think again here again. What are the restrictions on sine? It's between negative pi over 2 and positive pi over 2. Alright, where is our y coordinate 0? So at 1, 0, so the sine of 0 equals 0. So my angle here is 0 degrees, which is also 0 radians. Alright, sine again. So my restrictions are between negative pi over 2 and positive pi over 2. Since we want our result to be negative, we know sine is negative in the fourth quadrant. So that means we're going to have an angle down in the fourth quadrant. Alright, so what family is this? Hopefully said the 45 family. But since we want to be in the fourth quadrant and I'm restricted between negative pi over 2 and positive pi over 2, my answer is going to be negative pi over 4. So negative pi over 4, which is equal to negative 45 degrees. Alright, tangent. Here again we're restricted between negative pi over 2 and positive pi over 2. Alright, so we need to figure out what angle has a tangent of 1? And we want a positive 1, so that means we're going to be in the first quadrant. Alright, an angle with a tangent of positive 1 is going to be 45. So my answer is 45. Pi over 4 radians are 45 degrees. Alright, how about cosine? Cosine restricted to from 0 to pi. Alright, now, what angle has a cosine of 2? Well, you're probably scratching your head right now. Cosine of 2? Well, it's not possible. Remember, cosine can only be between -1 and 1. So we can't have an angle with a cosine of 2. So that means this is not possible. Alright, let's look at solving equations now. Alright, so we're going to solve this equation. What angle has a cosine value of square root of 2 over 2? Now notice our restrictions. So we're told that we have to be between 270 and 360. So we're only in this quadrant. Alright, well cosine, we want a theta that has a cosine. So theta is equal to the inverse cosine of square root of 2 over 2. Well, that's the 45 family. Alright, what is the 45 family member in the fourth quadrant? Well, let's count 45s. You got 1, 2, 3, 4, 5, 6, 7. So this is 7 pi over 4, which is 315 degrees. Since our problem started out in degrees, we want to continue in degrees. So that means theta is equal to 315 degrees. Alright, find the measure of the angle theta in the triangle shown. Alright, so we're looking for this angle measurement. Here's where you're going to have to use a calculator. So this is opposite hypotenuse. So this is sine. This should be a familiar problem that you did in geometry. So this is going to be the sine of theta is equal to 5 over 13. Alright, so theta is going to be the inverse sine of 5 over 13. Put this in your calculator. Make sure your calculator's in degree. And we should get about 22.6 degrees, which we're not going to write as radians. Degrees are fine. But this would have to be a calculator question. Alright, solve the following. So we want to know what angle has a sine of negative square root of 2 over 2. And notice that we're on the entire circle here. So where is sine negative? Well, sine is negative in the third quadrant and the fourth quadrant. Alright, what family member is this? 45. So we want to know what is the 45 degree measure in the third quadrant and in the fourth quadrant. Alright, so 1, 2, 3, 4, 5. This is 5 pi over 4, and this is 7 pi over 4. Since this is in radians, we want our answer in radians. So we're going to have two answers. X is equal to 5 pi over 4 and 7 pi over 4. If they tell me the arc tangent is 5 over 12, then I can set up, this is going to represent an angle, so I can set up the following triangle. And because it's tangent, I know that 5 is opposite and 12 is adjacent. Now, it's asking me for cosine. Cosine is defined as adjacent over hypotenuse. So that means I need to find my hypotenuse. Alright, so hopefully you remember your Pythagorean triple. So the hypotenuse is 13. So now they ask us cosine. What's the cosine of this angle? Well, cosine is adjacent over hypotenuse. So the cosine of theta is equal to 12 over 13. So that's our answer, 12 over 13.